This is Geometry, section 5.2, perpendicular bisectors and angle bisectors. So a perpendicular segment bisector is just like it sounds. A bisector is something that cuts something in half. So it divides a segment into two congruent pieces and is perpendicular to it. So remember, the upside down T means perpendicular, just like right here. So classify each of the following as a bisector, perpendicular, perpendicular bisector, or neither. So this first one, this is not perpendicular and it's not cutting this segment in half, so this would be neither. Here, we've got a right angle here, so we know these two things are perpendicular, but it is not cutting this segment into two equal pieces, so that would just be perpendicular. Here, we've got a segment, and these two tick marks mean that these two pieces are congruent to each other, so this is a perpendicular bisector. Here, this line cuts this segment into two congruent pieces, so this is a bisector, but it's not perpendicular to it. That's just a bisector. Here, we've got a right angle here, and it's cutting the segment into two congruent pieces, so that's a perpendicular bisector. Here, it looks like these two lines are perpendicular, but we don't have the mark that tells us that they are, so we can't say that those are perpendicular. We have to say neither because they're both lines, and I can't bisect a line because a line is never ending. So draw the following and mark the diagram accordingly. PS bisects AM. So draw segment AM. So PS bisects AM, but PS is not perpendicular to AM. So if it bisects it, it cuts it in the middle. So this could be segment PS. It's not perpendicular, but it is a bisector. Next one, NO is the perpendicular bisector of YS. So NO is the perpendicular bisector of YS, meaning NO cuts YS in half. So YS is here. NO is the one perpendicular to that and the one cutting it in half. Okay. The word equidistant. The word equidistant just means equally or the same distance away. So equally distant away, just like it sounds. So we've got a perpendicular bisector theorem. Perpendicular bisector theorem says any point on a perpendicular bisector is equidistant from the two endpoints. Okay, so here I've got a segment with two endpoints. So if I have a perpendicular bisector, we'll say this is my perpendicular bisector of this segment. So any point, perpendicular bisector theorem says any point on this line is going to be the same distance away from these two endpoints. So if I pick a point here, the distance from here to this endpoint is the same as the distance to this endpoint. So these two pieces would be congruent. Same thing if I picked a point all the way down here. This distance would be the same as this distance. And the converse of the theorem is also true. So if you pick a point on this line, if you don't know it's the perpendicular bisector, but you pick a point on the line and they're the same distance away from the endpoints, then you can say it's the perpendicular bisector. So here we're told that HR is the perpendicular bisector of ME. We've got to find all these variables. So since it's the perpendicular bisector, so HR is the perpendicular bisector, so we just learned that any point on that line, so R for example, is going to be the same distance away from M as it is from E. So it tells us this piece right here is 9, which means V also has to be 9. That also means that this creates an isosceles triangle. So we've learned about isosceles triangles that if these two segments are congruent, then these two angles are congruent. So if this is 56 right here, Z also has to be 56 degrees. Y, since this is the perpendicular bisector, this must be a right angle right here because these two things have to be perpendicular. So Y has to be 90 degrees. Since it's a bisector, this piece right here has to be congruent to this piece right here. So X has to equal 5. And to find U and W are both going to be the same because we've got two congruent triangles here. So if this is 56, this is 90. We add those up. We get 146 and we subtract that from 180 to find this angle right here, which is the same as this angle right here. So 180 minus 46 gives us 34 for each of these. Here we've got PS as the perpendicular bisector of AB. So this line is cutting this segment in half. So we've got to decide, we've got a bunch of segments on here and a couple angles. We've got to decide what the relationship between all of these pieces are, which ones are congruent to which. So it says AQ, which is right here, is congruent to what? Well, AQ, if this is a perpendicular bisector, AQ has to be congruent to BQ because this segment is being cut in half. So that would be BQ. SB, so any point on the perpendicular bisector is the same distance away from both endpoints. So the distance from S to B has to be the same as the distance from S to A. So these two segments are congruent. BQ, same thing as before. So if AQ was congruent to BQ, then BQ must be congruent to AQ. RB is right here. So the distance from R to B has to be the same as the distance from R to A. AP, distance from P to A, since this is a perpendicular bisector, has to be the same as the distance from P to B. AB and PR, what's the relationship? So AB, PR, those two things we know are perpendicular. Find the measure of angle SQB. SQB is a right angle, so it's 90 degrees. And then angle QBS is congruent to angle what? So QBS, so this whole angle right here has to be congruent to this whole angle right here, since this piece is congruent to this piece, and that creates an isosceles triangle. So that would be angle QAS. Okay. On the back, if we were in class, we would actually measure the distance from A to this line, and A to this line, B to this line, and B to this line. We would find that the distances from these points to each side of this angle, since this is an angle bisector, we know that because these pieces are congruent, they're both 37 degrees. So we would find that a point on the angle bisector is actually the same distance away from both sides of the angle, just like a point on the perpendicular bisector is the same distance away from both endpoints. So angle bisector theorem, so if a point is on the angle bisector, then the point is equidistant, meaning the same distance away, to both sides of the angle, if you measure it at a right angle. So the shortest distance from a point to a line is straight across at a right angle. So we have to measure it at a right angle. So just restating, this is called the angle bisector theorem. So if a point is on the angle bisector of an angle, then the point is equidistant to the sides of the angle if you measure it perpendicularly. So if we've got an angle bisector, two congruent angles, then a point is going to be the same distance away from both of these sides if I measure it at a right angle. So AP is the perpendicular bisector of angle CAT. So this is a perpendicular, sorry, not a perpendicular bisector, an angle bisector. So if it's an angle bisector, we know these two pieces have to be equal. So solve for x. I could write the equation 3x equals 36. Why can I write this equation? Because I've got two congruent angles since I have an angle bisector. So since these angles are congruent, I can set them equal to each other to solve for x. So when I solve for x, I divide by 3, and I get that x equals 12. Equation for y, well, we just learned that a point on the angle bisector is going to be the same distance away from both sides of the angle. So these two things are also going to be equal to each other. 4y equals 24. So I can write this equation because P is equidistant to side AT and AC. It's equidistant to both of those sides. So when we solve for y, we divide by 4. We get y equals 6. Okay, equation for AP. So this is actually the Pythagorean theorem. So we've got equation for AP. I've got a right triangle right here. So if I look at this right triangle, two sides are 32 and 24. So a squared plus b squared equals c squared. 32 plus 24 equals c squared, where c is the hypotenuse, which is AB. 32 squared plus 24 squared gives me 1600. So 1600 equals c squared. And when I take the square root of both sides, I get that AP or C equals 40.